sampling, whereby in random sampling you just pick data in a random manner without considering the position, the number. Just pick data in a random manner. So there are two ways of picking a data. You can pick it in a chronological order or in a random manner. So in random sampling, we just go randomly. So you pick 20, you pick 40, you pick 29, 27, and 32. That's what we call random sampling. Table of random numbers. So these are numbers which are presented in a random manner. We have 6, 8, 4, 2, 5, 7. So numbers have actually been presented in a random what? Manner. Now systematic sample. A systematic sample is a sample in which each member of the population is assigned a number. A starting number is randomly selected and the sample member are selected at regular interval. So again, when you talk about systematic, systematic comes from system. System means there is order which must be followed. So in the systematic sampling, data is actually picked on the basis of the number which has been given. So starting number is randomly selected and the sample members are selected at what? At a regular interval. So you need to give an interval. After what period? After what numbers that you will be picking the data. Now, table of random numbers. Now, this is what we mean by. So here is a representation of how the data can be presented. Now, you will be picking data in a systematic manner. Like, check at the yellow. They are appearing after what interval? What is the interval of the appearing of the number? Every fourth number is chosen. Now, that is what we mean by systematic. You are actually choosing a number on the basis of its appearance. Let me repeat. So this is actually a presentation of a data. You have a data which has been given and the data has been organized in a very systematic manner. Now what happens is that you choose a data in a random manner. Starting number is randomly selected. So in our case, we are starting with the first data, which is now given yellow. So the first one yellow, after the fourth, you pick the data. So we are picking every fourth number. So every fourth member is chosen for a research. So if you are 20, every fourth number will always qualify for the research, will be sample for the research. Is that clear? So sampling fractions, ratio between sample size and population size. So you can actually decide to work on ratios. 2/4, 1/2. So that gives you the essence. Now we come back to the systematic sampling using the same data that we presented in our random sampling. So in this case, we are actually sampling a data on the basis of their appearance. Now, are you getting the procedures here? Yes? First, you choose the first interval. Then the rest will follow. So between 8 to 28, what is the difference? 8 to 28. What is the difference? 20, is it? 28 to 48. What is the difference? The 20. Is it okay? Now, are you getting the systematic sampling? You must be systematic in terms of you choose the first number and then you determine what will be your interval numbers. After how long? After how many numbers? After how many population? After how many members that you will pick the next number? So if it is 10, maintain 10. That is your interval. If it is 20, maintain 20. That is your interval. Are we together? Now we come to clusters samples. Clusters sample. A cluster sample has all members from randomly selected segment of a population. Has all members from randomly selected segment of population. So in the clusters, we are doing what you call random selection. This is used when the population falls into naturally occurring subgroups. Now, if your data is presented in a manner that there is a particular pattern which is appearing in the representation of your population, then when you are using clusters, you're very much sure that as you pick any cluster, it will give the representation of the population. Remember, sample gives the representation of the population. Now, this is our cluster. City of Nairobi divided into city blocks. Now, we are doing what you call clustering. So in each and every city blocks, we are picking data randomly. And in each and every random collection, they actually carry the same characteristics. They are all in squares. Is it okay? So if I pick any square, it will give a representation of the rest squares. If I pick any city block, it will give a representation of the remaining blocks that I have not picked. So these blocks that I've picked gives me a representation of other blocks which I have not picked. So in the cluster, the data is widely spread, but in your representation or collection of data, you just pick data on the basis that the data is occurring in a subgroup behavior. So all members in each selected groups are used and they bear the same characteristics, they have the same texture, they have the same representation. So whichever block I pick, it will give the representation of other. So a group of small sampling units close to each other, crowding together in the same area of the presentation. Now this is more homely. Can you see the city in the hills? Now if I pick a data from any part of this randomly, the data must give me the representation of all other houses, of all other buildings. So this is actually representation of buildings which are all over. But now I'm sampling only 4 buildings. I'm sampling 4 buildings in this side and 4 buildings in this side. And I can again decide 4 in this side. Are we together? So these are clusters. The 2 gives us the clusters. So the population that you are picking, the sample that you are picking represents clustering. So this is what you call clusters. So cluster sampling. So are you getting the point? Is the point coming home? So we selected 1 and we selected 2, which gives a representation of all other selected pads. Now, stratified sample. A stratified sample has members from each segment of a population. Has members from each segment of the population. So when you talk about stratified sample, the sample that you are picking has members in each population. This ensures that each segment from the population are represented. Freshmen. How many freshmen do you look or are you seeing? Sophomores. Juniors. So this is actually the kind of population that we have. We have freshmen, we have sophomores, and we have juniors. Then you're told sample. So in your sampling, and then we have seniors. So there is actually 4 representation of this is all population. All these are population. The freshmen, the sophomores, the juniors, and the seniors are the representation of the what? Population. Now check out, is it violet or is it purple? You know, men, we are colorblind. Which color is that? Stella, which color is that? Yes? Or you are colorblind? Is it violet or purple? It looks more violet. You know, men, we are colorblind. Okay. So now look at the stratified sampling. We have the 2 cycle in the freshman. We have the 3 cycle in the sophomore. We have 2 in the junior, and then we have 3 in the senior. So your picking of data give a representation of all other information in the data.